In this problem, I'm going to talk about the procedure to solve a 2D kinematic problem. So in this problem, you have a person who's going to throw a ball towards a wall. So here's the wall. And you know that the person's here, and they throw the ball at a initial velocity of 25 meters per second. Now, they don't say x or y, so this is just the magnitude of the velocity. And they tell you it's at a 40-degree angle here. Okay. They also tell you that the release point is 22 meters from the wall. And they want you to find, if I track this point here, and this is a parabolic path, how far this is. So, you know the initial launch velocity, 25 meters per second. You know the angle is 40 degrees. It's 22 meters from the wall, from the release point. I'm using that as my reference right here. And so what you need to do is you need to find a couple things. We want to find out why. How far above the release point does it hit the wall? And I don't know if it hits it on its upward swing, exactly at the top of its trajectory, or the downward swing. But in general, it's going to follow a parabolic path. B, I want to find the horizontal component as it hits the wall, so Vx. C, I want to find the vertical velocity as it hits the wall. And then D, I want to find out, does it hit it on its way up? Does it hit it when it's at its apex, or does it hit it on the way down? Okay, and one of the things I'll address here is sometimes they ask for what angle does it hit the wall with, or does it hit the ground with, which we'll talk about. So the solution for the kinematics model, 3 steps. List the equation, list variables, and solve. So I'm going to list all of my equations. X equals x0 plus vx0t plus 1/2 at squared. Vx is equal to vx0 plus at. Vx squared is equal to vx0 squared plus 2ax minus x0. And then y. Usually I like to have these next to each other, but for space here, because my template I don't have enough space, but I'll just stack them. Y equals y0 plus vy0t plus 1/2. Now remember, this is gt squared because it's gravity. Vy is equal to vy0 plus gt t, and vy squared is equal to. So at this point, I'm not trying to figure anything out. I'm just organizing myself. So I got my equations there. My variables. So I list all the variables. So it's like 2 kinematics problem in the x and the y direction. x0, x, vx0, vx, a, and t. y0, y, vy0, vy, and g. I don't write t a second time because it's the same time. We have a common time for this, for the horizontal and the vertical motion. Okay, so just like in the regular kinematics problem, I'm going to put my origin, where the motion begins or it originates from, which is right over here. That's my origin. So I'm going to overlay an xy axis on top of things. So if I do that, we know this is 0 meters. And I know this is 0 meters. It does travel, we know, 22 meters. But I don't know how far it goes up. We need to find that. The Vx0. So what I was given was V0. I don't know Vx0. So as a little side dish, I do it in the list variables part. Side dish. I actually do a little scratch work. So I say, okay, I have this triangle here, basically. This is 25, it's hypotenuse. This is a 40-degree angle. 40-degree angle here. So I need to find the horizontal part here and the vertical part there. So if I do a little trigonometry, I can see that if this is cosine here, so Vx0 is equal to V0, which is this guy, the hypotenuse. Cosine theta, and y0 is equal to v0 sine theta. This is the sine component, or opposite, and this is the cosine component. So I can fill those numbers in. I'll let you do the math there and fill those in. We don't have any force or air resistance in the x direction, so whatever it is here is the same it is there, which implies 0 meters per second acceleration in the x direction. And how long does it take? I have no idea. Okay. In the y direction, the y velocity, I do not know. In fact, I don't know if it's going to be positive, negative, or 0. I don't know if it's going to hit an upward swing, which would imply positive, or the downward swing, which it's going to be negative, or if it's 0, in which case it hits it at the very apex. I do know this, though. Negative 9.8 meters per second squared. 9.8 J. So those are the variables I have for the motion. So if I have these variables here, I should be able to use these equations, and again, here's some scratch work. That goes away, that goes away, and that goes away, basically. I need to solve for the variable y here. Okay, so using a combination of variables in the x direction and y direction, I should be able to solve for this. I need to solve for this, which if there's no acceleration in the x direction, it's the same, which we know. And we need to solve for Vy. You have a choice here for Vy's. All right. So those addresses, that addresses B and C. The direction of the motion upon hitting will be basically the sine. And then lastly here, some questions ask about the angle when it hits. So let's just say, for sake of argument, that it hits the wall on its downward arc, like right there. If I know Vx and Vy, which I'm going to solve for down here, I can find the magnitude of the velocity using Pythagorean theorem, because I can make a little right triangle here. That's supposed to be a right triangle. And then the angle at which it hits is this angle right here. So using sine, cosine, tangent, because I know all three sides of the triangle, I can find the angle with which it hits. Now, if the problem states with respect to the horizontal, this is the horizontal there, so they mean this guy. If they say with respect to the vertical, which is this, then they mean this angle down here. I'll call it phi. Either way, you're finding the angles of a right triangle. And since you know all sides, you can use any trigonometric function that you like. So that's the basic setup of a 2D kinematics problem.